Hi guys, it's Elissa. Mrs. Hill so kindly lent me her iPad to try and make you guys a video here, so I'm going to give it my best shot, and if I screw up you can all yell at me tomorrow, whatever. But tonight's topic is going to be integrals of exponentials and logs. Well, first things first, we need to go over our rule. Anytime you integrate e to the x dx, you're going to end up with e to the x plus c. It's a pretty simple rule. It's the same thing on each end, so why don't we try our first example. Our first one's going to be the integral of 6 times e to the x dx. Now, before we can integrate, we got to do something with this 6. So our first move, we're going to pull that 6 out in front, times the integral of e to the x dx. Then we're going to integrate and say that it's 6 times the quantity e to the x plus c, and distribute that 6. You get 6 e to the x plus 6c, and that 6c is really just another constant, so we can just call it c. So our final answer ends up being 6 e to the x plus c. So this time we're going to integrate e to the x over 6. And since that 6 here, or that 1/6, is in the exponent, we can't just pull it out. So we're going to have to do some u sub. Now, we're going to let our u equal this entire exponent. So u is going to equal x over 6. Our du is going to equal 1/6, then the derivative of x, dx. Now we're going to solve for dx. So dx equals 6 du. Now when we go back and integrate, we now have e to the u times 6 du. And again, just like that last one, we can pull that 6 right out front. So we have 6 times the integral of e to the u du. And you know when we integrate that, we're going to get 6 e to the u plus c. Now, all we're going to do is take our u and plug it back in down here. And we end up with 6 times e to the x over 6 plus c. So this one's a little bit trickier. For our u sub, we're going to let our u equal 6 over x, and our du is going to equal negative 6 over x squared dx. Now we're going to solve for dx, and we're going to get x squared du all over negative 6 equals dx. So you'll see when we plug that back in, we get e to the u over x squared times x squared du all over negative 6. And those cancel out. So we're going to pull that negative 1/6 out front times the integral of e to the u du. Now the integral of e to the u is just e to the u, so we're ending up with 1/6 e to the u plus c, or negative 1/6, sorry. And that's going to be negative 1/6 e to the 6 over x plus c. Now the previous few integrals we've done did not have bounds on them. They were indefinite integrals. This one's going to be a definite integral because we have bounds of 1 and 2. So we're going to integrate the same way. We let our u equal x squared plus 1. Our du is going to be 2x dx. So that means our dx is equal to du all over 2x. Now, one thing you need to remember when you're integrating a function in terms of u is you need to turn your bounds in terms of u. So instead of using bounds of 1 to 2, we're going to plug our 1 and 2 back into this u equation. So we're going to let u equal our lower bound 1 squared plus 1, so that's 2. So our new lower bound is 2. And our upper bound, we're going to do the same thing. We're going to let x equal 2. So 2 squared plus 1 is 5. And we're going to integrate the same exact way. So we have x times e to the u times du over 2x. Our x's so nicely cancel out. That leaves us the integral from 2 to 5 of e to the u du. And we all know the integral of e to the u is just e to the u. And since we changed our bounds in terms of u, we don't have to plug our u back in terms of x. So we leave it as e to the u. And now we have e to the 5 minus e squared. Piece of cake. Oh shoot, I almost forgot. This little 2 right here. That'll get you every time. You got to make sure you pull that 1/2 out every single time. So our answer is actually going to be e to the 5th minus e squared all over 2. That's my fault. My bad. So our second rule for tonight is going to be the integral of du over u equals the natural log of the absolute value of u plus c. Now I drew these arrows for a reason. These are very important. I'm going to even write it down. Very important. Anytime you integrate du over u and you end up with the ln of u, you better include these absolute value symbols. So on this example, one big mistake that we catch a lot of people doing is that they're not making like a beaver and splitting. Anytime you have a polynomial over a monomial, you got one term on the bottom here, you better be making like this beaver here and splitting that wood. So you're going to divide each and every term by that x. So I'm going to scroll down here. We're going to end up with, let me get my pen, the integral of 3x minus 4 plus 5 over x dx. So now it's just a simple integration. When you integrate 3x, you get 3 halves x squared, and then minus 4x, and plus 5 times the natural log of the absolute value of x plus c. So when I first looked at this problem, I was thinking, what the heck? How am I going to integrate this? I couldn't even see a way. But then I realized that when you derive e to the x, it's just e to the x. So if we do a u sub, we could do u equals e to the 3x minus 4. Have our du be 3 e to the 3x dx. So that makes our dx du over 3 e to the 3x. And when we plug that back in, we get 2 e to the 3x all over u times du over 3 e to the 3x. And look at that. Those cancel out nicely. I'm going to pull out the 2/3. So we get 2/3 integral of du over u, which equals 2/3 times the natural log of the absolute value of u plus c. And then when we plug back in our u, we get 2/3 ln of e to the 3x minus 4 plus c. So this one's very similar to all the other ones we've done today. This one's a definite integral though, because we have bounds. So I'll give you a hint. We're going to do some u sub, just like every other problem we've done on here. So I'm going to have you guys try it, and why don't you pause it, do it on your own, and see what you get. So as you can see, I let my u equal 2x cubed plus 8, and that makes our du 6x squared dx. So our dx is du over 6x squared. I plugged it back in, got 3x squared over u times du over 6x squared. The x squareds cancel out nicely. We're left with 1/2 integral of du over u. And according to our rule, the integral of du over u is really the natural log of the absolute value of u. Now, I purposely left out the bounds because I wanted to emphasize the fact that we're still in terms of u down here, so our bounds need to be in terms of u. So if our first bound up here was a 0, we're going to plug that 0 in for u, or for x. So we get 2 times 0 cubed plus 8, which is really 8. So our lower bound is going to be an 8. And our upper bound, we're going to do the same thing with that 1. We're going to get 2 times 1 cubed plus 8, which is 10. So plug in your bounds. We end up with 1/2 ln of 10 minus 1/2 ln of 8. And using your log properties, you can clean that up a little bit. So we're ending up with 1/2 ln of 10 over 8, which is really the natural log of radical 10 over radical 8. If you want to clean that up, that's fine. The AP exam might show different styles, so you're definitely going to need to know your log properties to get the right answer on the AP. Yay, trig functions! Gotta love these. So when I first looked at this problem, I was thinking that you might be able to use either function, either the top or the bottom, as our u for u sub, but then I realized you might want to get rid of this 3, and the only way to do that is to use it as your u and take its derivative, because the derivative of a constant is 0. So I'm going to let my u equal the cosine of 2x plus 3. So that makes my du negative 2 sine of 2x dx. And our dx is du over negative 2 sine of 2x. Plug that back in. We're going to get a 4 sine of 2x over u times du over negative 2 sine of 2x. Those cancel out. Pull out our 4 over negative 2. I'm just going to make that a negative 2 times the integral of du over u, which is negative 2 times the natural log of the absolute value of u plus c. And simply plug it back in. We get negative 2 natural log of the cosine of 2x plus 3 plus c. So we saved the trickiest problem for last, and of course we decided it's going to count as your quiz grade, ding ding ding. So I suggest you get this done. They want f of e, and I'll give you a hint. You're going to use your first fundamental theorem of calculus. So good luck, and I'll see you guys tomorrow.